Hello, this is Sergio Cicero from University of Cantabria, and I'm going to present the work entitled Fracture Mechanics Testing of Irradiated RPV steels, reactor pressure vessel steels by means of subsized specimens, FRACTESUS project. This is actually a preliminary dissemination paper of about a project which is about to start in the second semester of this 2020. You see here a number of authors, which are the main contributors to the project, the work package leaders, and some of my colleagues at University of Cantabria. The contents are divided into these four sections: an introduction, why this project, materials and methods, how we will approach the topics analyzed by the project, the expected results, and finally the conclusion. So, what is FRACTESUS? FRACTESUS was initially a proposal of a European project within the Euratom Work Program 2019-2020. Within the section NF RP04, Innovation for Generation 2 and 3 reactors. So, ongoing operating reactors and new developed reactors. It was positively evaluated and reached the stage of grant agreement in February 2020, with the kickoff meeting being expected in October 2020. The project duration is 48 months, 4 years, and we have received financing from the European Union, a grant of almost 3 million euros out of 4.4 million euros of budget for the project, overall budget. So reactor pressure vessels, its aging, their aging is rated traditionally number one in the list of safety concerns in the nuclear MPP context, nuclear power plant context. Why? It's the primary barrier against the release of radioactive material. Its failure is excluded by design. It cannot, of course, be replaced, and it suffers from hardening and toughness degradation as a result of thermal aging and irradiation. Consequently, from the very beginning, from the very first nuclear power plants, there were surveillance programs to control this evolution in the material properties along the plant operation. And typically, Charpy-sized specimens were introduced into the reactor and taken from time to time to test and see how material properties change along the time. The problem is that these surveillance capsules are now practically exhausted. There is no extra material to test and to ensure that the long-term operation, that the life extensions may be approved without safety concerns. And also, it has been reported that there are presence of local material heterogeneity and small defects in large forgings. It has become an issue, actually. And this cannot easily be analyzed by using traditional fractured toughness specimens. So, with the aim of solving these issues, that is the lack of material to be tested, with the possibility of reusing tested specimens, also valorization of irradiated material, because the required material in future surveillance programs would be reduced, for example. For all these reasons, the FRACTESUS consortium proposed this project, and it was finally approved by the European Commission. Um, then, what we are proposing is to use small-sized specimens to measure fracture toughness directly. The reference small specimens to be used is miniature compact tensile specimen 0.16T, also known as that, which is obtained from the sections of Charpy specimen. So we can obtain up to 8 specimens from a broken Charpy specimen. This approach is designed to increase the safety level through direct fracture toughness estimations rather than semi-empirical approaches such as Charpy, significantly increase the data points of fracture toughness evolution along the time, and characterization of local material properties in the case of in case there is material inhomogeneity. So which is our approach? The consortium is composed of 22 organizations from Europe, Japan, USA, and Canada. It is coordinated by Cicero in Belgium. So the project has gained attraction from other sites of the world, not only Europe. And it's organized in a traditional work package scheme with work package 1 dealing with stakeholder involvements. All the different stakeholders related to nuclear industry are incorporated in this work package. Work package 2 develops the material selection and the fabrication of the specimens, especially the 0.16 CT specimens. Work package 3 deals with the fracture mechanics testing and post-test analysis. There is a need of understanding what we are obtaining experimentally. Work package 4 provides the modeling and support of work package 3. Mechanistic understanding of what we are obtaining in the lab, it's really important here. And with all these, work package 5 will provide the guidelines about how to measure fracture toughness through mini specimens, mini fracture specimens. There are two transversal work packages. Work package 6 that deals with dissemination, training and education and data management. This is coordinated by University of Canterbury. And finally, the work package 7, general management, which is led by the project coordinator SDK in Belgium. This is how we will work in the next 4 years with the aim of establishing reliable criteria to test fracture in reactor pressure vessels. Because traditionally, despite the potential of this technique, when incorporating this technique into official requirements and standards, there are still concerns. Our intention is to provide confidence on this technique so that it can be incorporated in the future by regulators. So, concerning the results, I just include here a table with some of the main deliverables. Of course, we will have a big data set of experimental results on small specimens. I have mentioned the 0.16 CT specimens, but we will also use, for example, a small punch specimens on an in-kind basis. We will provide reports on estimation of mechanical properties of unirradiated and irradiated RPV steels, a report on qualification of mini fracture toughness specimens for testing. We will provide special sessions at international conferences. We will provide FRACTESUS seminars to spread the knowledge generated within the consortium, and we will generate an European group of experts on this kind of techniques, which will be more and more important in the nuclear industry. So, with all this, are the following. Mini CT specimens provide a wide range of possibilities and advantages. For example, and as I mentioned before, multiplication of data points, valorization of tested specimens, less material to be irradiated in the future, and the possibility to measure local toughness and to detect heterogeneities. With the aim of demonstrating the capacity of these techniques, the FRACTESUS consortium generated the FRACTESUS proposal that has finally obtained a grant provided by the European Commission. And the final goal of the project is to join European and international efforts to establish the foundation of a small specimen fracture toughness validation and demonstration to achieve the change in code and standards, and to deal with the national regulatory authority concerns. So the project has not started yet, but you are all invited to provide feedback on this approach and all along the development of the project. That's all, and I'm now open for questions. Thank you very much.